minimize it and go to the other one.
Okay. Hello, this is Miss Waters, and today we're going to go over special cases of Lewis structures. And so on the special cases, we're going to go ahead and go over how we do this. So your periodic table is going to be important to use. So make sure that you have your periodic table with you, and we're going to go from there. So carbon is in group 4. So it has 4 valence electrons, but I have 2 atoms of it, so that is 8 electrons. Hydrogen has 1 valence electron. I have 6 atoms of it, so that is 6 electrons for a total of 14 electrons. Well, carbon, like most of the elements, needs 8 electrons. I have 2 of them, so that is 16 electrons. And hydrogen is one of our special cases. It needs 2 electrons because it wants to be like helium. So 2 electrons times 6 atoms gives me 12 electrons. So adding that up, I get 28 electrons. Okay, so now bonds, I get 28 minus 14 divided by 2, and that gives me 7 bonds. So in this case, carbon is going to be bonded to carbon in the center. Hydrogen must be an element on the outside. So we're going to take and bond hydrogens all the way around the carbons, like so. Okay. Now, hydrogen, so each of the lines is 2 electrons. So I have 7 lines, so that's 14 electrons, and that's what I have there is 14 electrons. So that means that I will have no dots, which is true because hydrogen will never ever have dots in a Lewis structure because it only makes one bond, and that bond will have the 2 electrons, so the line. Okay. And so just a reminder, when you're dealing with these, all elements need 8 except for hydrogen, which needs 2. It has 1 electron, it needs 2. Beryllium, which has 2, needs 4. And boron, which has 3, needs 6. Everything else is going to want 8. So you need to memorize those first 3 elements, the hydrogen, the beryllium, and the boron. Okay, so continuing on. Hydrogen is in group 1, so it has 1 electron. Chlorine is in group 7, so it has 7 electrons. And oxygen is in group 6, so it has 6 electrons, but I have 3 of them, 3 atoms of that, so that's 18 electrons. So adding that up, I get 26 electrons. Okay. Now, hydrogen needs 2 electrons. Chlorine needs 8 electrons, and oxygen needs 8 electrons times 3. And that gives me 24 electrons there for a total of 34 electrons. Okay, so now we're going to take 34 minus 26. Okay, and we're going to divide it by 2. And we will get on our is 4, because that's 8, so divided by 2 is 4. So in this case, chlorine's in the center. It's bonded to a hydrogen, an oxygen, an oxygen, and an oxygen. Okay, we need 26 electrons. We won't put any on H, so we're going to start with around the O's. So we have 8 electrons already in the bonds. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26. And we are done. Okay, so remember that our lines and dots must add up to our have column. Our need column is used to help us figure out how many bonds that we would have. Okay, so if the total valence in the drawing exceeds the valence allowed for the molecule, we're going to use double or triple bonds. If the number of bonds we memorize on the periodic table may not always match. So moving on here. So again, oxygen is in group 6. So oxygen has 6 electrons times 2, which gives me 12 electrons. Oxygen needs 8 electrons times 2, which gives me 16 electrons. So in this case, 16 minus 12 divided by 2 gives me 2 bonds. So we're going to have oxygen bonded to oxygen, but it's going to be a double bond. So we have 2 bonds. And then we need a total of 12 electrons. That's 4 between the 2 lines. So 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so there we go. And the reason why the electrons are kind of diagonal is because when I put lone pairs on an atom, they tend to move away from the bonds or make the bonds bend. In this case, the bond wouldn't bend because I only have 2 elements, so it would be linear. All right, moving on. Nitrogen is in group 5 on the periodic table, so it has 5 electrons times 2, which gives me 10 electrons. Nitrogen needs 8 electrons times 2, which gives me 16 electrons. So 16 minus 10 divided by 2 gives me 3 bonds. So we're going to have nitrogen triple bonded this time to another nitrogen. So that gives me 6 electrons. I need 10. So that means that I will have 2 electrons on each nitrogen furthest away from the bonds. Okay. So moving on. Sulfur is in group 6 on the periodic table. Oxygen is also in group 6 on the periodic table, and I have 2 of them for 12 electrons. Adding that all up, I have 18 electrons. Sulfur needs 8 electrons. Oxygen also needs 8 electrons times 2, which gives me 16 electrons, for a total of 24 electrons. So 24 minus 18 divided by 2 gives me 3 bonds. So sulfur is going to be my central atom since I only have one of those. And it's going to be bonded to oxygen and bonded to oxygen. Well, now I said I have 3 bonds, so one of them has to be a double bond. Okay. Now, so that is 6 electrons. I need 18. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay, so we surround the single bonded oxygen with 6 electrons. The double bonded oxygen only gets 2 electrons, and I still have a lone pair, so 2 dots on the sulfur. Okay, so moving on. Carbon is in group 4 on the periodic table, so it has 4 valence electrons. Oxygen has 6 valence electrons for a total of 10 electrons. Carbon needs 8 electrons. Oxygen also needs 8 electrons for a total of 16 electrons. So now 16 minus 10 divided by 2 gives me 3 bonds. So I'm going to have carbon triple bonded to oxygen. That gives me 6 electrons. I need 4 more to get my 10. So 2 of them go on carbon and 2 of them go on oxygen. So there is my structure for carbon monoxide. Okay. So remember, if a molecule has a charge, for example, polyatomic ions, you must add or subtract from the have column and only the have column. You're going to not change anything about the need column. So positive charges, you're going to subtract electrons because you have less electrons. That's why it has a positive charge. For a negative ion, you're going to add to the total because you have more electrons. Okay, so let's try these. They're similar in how we do them. So sulfur is in group 6 still, so I have 6 electrons. Oxygen is also in group 6, so I have 6 electrons, but I have 4 atoms of it. So that gives me 24. Adding that up, I get 30 electrons. Well, I'm not done because I have a -2 charge over here. So I need to add 2 more electrons to the have column. So that gives me 32 electrons. Now in the need column, I'm going to do nothing different. I'm just going to do the same thing that I've been normally doing. Sulfur needs 8 electrons. Oxygen also needs 8 electrons, but I have 4 of them for a total of 32 there. So 32 and 8 gives me 40 electrons. So my need column has 40. So now to find out how many bonds I need, I have 40 minus 32 divided by 2, and that gives me 4 bonds. So in this case, I'm going to have sulfur in the center, bonded all the way around by oxygen. Okay, I have 8 electrons based on the 4 lines that I drew, and I need 32 electrons. So I'm going to surround each oxygen with 6 electrons. So we have 8 already, so watch. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. And notice that's how many I need in from my have column. And then because it has a charge, we put it in bracket with a -2 charge. Okay. All right. So you notice that we did, when we have negative, we add electrons. So this one we have a positive charge, so we're going to subtract electrons from the have column and the have column only. So nitrogen is in group 5 on the periodic table. It has 5 valence electrons. Hydrogen is in group 1 on the periodic table, and I have 4 of them, so I get 4 electrons there for a total of 9 electrons. Okay, so this should set off some warning bells in your head. Ding, ding, ding. I have an odd number of electrons. So if I try to divide this by 2, I'm not going to get my bonds to come out correctly. Well, I have a +1 charge, so I need to subtract 1 electron from here, giving me 8. So my need and have columns always must be even numbers. Okay, so I have 8 electrons there. So nitrogen needs 8 electrons. Hydrogen needs 2 electrons because that is one of our special cases, times 4 of them. So that gives me 8. So adding that up, I get 16 electrons. Again, I do not add or subtract from the need column as far as because of the charge. It stays the same. So now 16 minus 8 divided by 2 gives me 4 bonds. So again, nitrogen in the middle, surrounded by hydrogen. Okay. Okay, and in this case, I have a +1 charge. I need to place 8 electrons. Each line is 2 electrons. There's 4 lines, so I have my 8 electrons. So there's no dots, which makes total sense because remember, hydrogen never gets dots. Now, last one. Hydrogen has 1 electron because it is in group 1. There's 3 atoms of it, so I get 3 electrons. Oxygen is in group 6, so it has 6 electrons. So I get a total of 9 electrons. Again, the alarm bells should be going off in your head. Ding, ding, ding. I have an odd number. Now what do? Well, I have this positive 1 charge. So that tells me that I have 1 more proton than I do electron. So I'm going to subtract 1 electron from here, and I get 8 electrons. Okay. Now, hydrogen needs 2 electrons. There's 3 of them, so that gives me 6. Oxygen needs 8 electrons for a total of 14. Okay, so now I'm going to take 14 minus 8, divide it by 2, and we get 3 bonds. Okay, so again, oxygen is my central atom, and I'm going to have a hydrogen bonded to it, a hydrogen bonded to it, and a hydrogen bonded to it. And so I have 2, 4, 6 in my bonds. I need 8 electrons, so I need 2 dots. And the 2 dots are going to go on the oxygen because remember that hydrogen never ever gets dots. Again, it's got a charge, so we're going to put a +1 outside. And that is our Lewis structure for the hydronium ion. Okay, so be careful with your math and make sure that when you have charges, that when it's negative, you're adding electrons. When it's positive, you're subtracting ions. Have a great day, and I'll see you in the next video.